Starting. Good afternoon, good morning, good evening, wherever you might be in the world. I cannot believe I am talking to Drone Jesus now. Not only talking to Drone Jesus, but he's at CES, which is a thing, isn't it? It is a thing. It's a very long way from where I am in South Africa. But Autel have launched one particular, I think actually only one new drone launch there, I think. But it's pretty interesting. It has the sensors, it has all the stuff we'd expect in the modern world, but I think it has one feature that not many people seem to, not picked up, and that's this mesh business. And that's what I want to know about. John, thank you very much for joining us. Can you give us your CES tour of the drone first, and then explain to me about the mesh, please?
Well, real quickly, we'll talk, about the Max. That is the new release. We'll come right over here behind me. The Max obviously is a new drone for us. Geared a little bit with this payload, 14 for public safety. So let's go ahead and take a look at it. So I kind of say that it's a little bit more about public safety simply because of that sensor package. We've got laser rangefinder, 640 thermal camera. We look really close. We have an actual optical zoom, not a digital zoom in that little package right there. So we have an optical zoom. We also have our wide camera here for situational awareness to jump back and forth. So there's a lot of good things put into the sensor package here, and we're expecting certainly a lot more as far as what's coming. This is nice because, again, on the Max, very similar to what we could do with the Evo, is just removing 2 bolts and we'll be able to change payload. So this may not be the payload you want today, but we're working on future payloads to make maybe more mapping capabilities and things like that. So super proud and happy that we have such a small drone that still has a payload exchange, not toolless, but it's pretty close, being able to do mission specific. Another one is that we're using 360 cameras up here on the top for our obstacle avoidance. So we've got much bigger fisheye capability here to see fully around. Even though we have the cameras on the front, cameras on the back, we don't have cameras on the side. So
sorry, John. Can I stop you? Because remember, I'm very slow, so you have to explain things slowly to me. Did you say cameras on the front and the back, or are they sensors on the front and the back?
Sensors, but they are for optical avoidance sensors. So I still call them cameras, simply because they still have to see. One of the challenges we have with sunlight is that if it's blinding to these cameras for obstacle avoidance and the sun is late, it can't see very well. So when we have normal cameras, even though they are sensors, right? Looks like you're grabbing the Nano.
Yeah, because funny you should mention that, not seeing very well. Anyway, I do notice a few shout outs when I'm playing very high, but if I put it into sun, it warns. But anyway, sorry, we're not talking about that. Sorry, John.
No, you're okay. I'm just saying, that is a challenge with optical avoidance when we only use basically the sensor or a camera RGB sensor for that purpose. However, even though I'm just saying that we have them on the bottom to be able to see much visually further, but the one thing is that they also don't work well at night. When it's dark, super dark, these cameras can't see. They're not infrared, they're not near infrared, they're not anything. So when we were talking about that, what we've done specifically is design radar inside. So we have a millimeter wave radar that also transmits to it to help us with obstacle avoidance in very difficult places for these cameras to see. And I don't know of any other manufacturer that has actually done that.
And so there's a huge amount of sensor fusion then, I suppose, to pull all 100%. That data into one stream and go, maybe we should turn left. So when you say it's got a millimeter wave radar in there, what sort of distance does that work out to? And is that 360 degrees?
It's 360. The wave does do top and bottom primarily, but it does kind of sense around. So we have front, back, top, bottom. But we still have to be aware, a little bit on that side. So That's one thing about it. So the sensor, yeah, there's a lot of sensor packages put in here just to make it a bit more autonomous to some degree without the pilot having to do so much work. So I love prop guards, but I hate prop guards.
Sorry, say again.
So
You hate
I
drone
hate prop
guards?
guards. I hate prop guards. They end up being heavy. You know, they're not always effective on aircraft that need the flight time. You know, so if you're gonna put it in somewhere, I can. So another thing we just want to talk about on the floor on the Max here is first drone that I know of, and correct me if I'm wrong, that has a hot swappable single battery.
Yeah.
Hot swappable single battery. So it's really easy to do hot swaps with dual batteries or multiple batteries if that's in the design. But we basically are able to do a quick hot swap, keep the aircraft on for 30 seconds, and then put our ready to go turned on battery back in the back.
So I assume that obviously means you keep the GPS alive for that time as well.
That's right. GPS, video transmission, all telemetry is still being transmitted from the aircraft. As long as you do that in under 30 seconds, you have enough capacity inside the internal battery to run that, or capacity to run that. And then we're just doing that quick hot swap. So for public safety, any type of quick turnaround on the drone, even for some level, you know, some of our cinema guys that have to bring it back, hurry and quick and go, get it back up again to get those shots, you know.
Yeah. And did I read somewhere it's got a 15 seconds plug it in and go sort of time?
It's like I say, I keep it very conservative, so I try to keep it conservative. You know, 30 seconds. It's still a long time.
Yeah. Okay.
You know, if you're fumbling around for less than, you know, if you count it out, that's a long time for somebody to just pull that battery and put that battery back in.
So what am I confusing then? I thought I'd confuse. So is that 15 seconds from when you swap the batteries around, not 15 seconds from cold?
Yeah, 30 seconds.
30 seconds.
Yeah, so once battery removal is gone, you have a full 30 seconds before it shuts down. That is the design. You can do it in 5 seconds, but if you take longer than 30, then the drone will restart. Will have to be restarted.
So the millimeter wave radar, the great center that you can swap. And how far out? I know people are going to ask. You're getting some. You can't see the comments, but people are. Darvin's asking a good one. Will the radar be able to detect plastic fiberglass obstacles? That's an interesting one.
Anything that creates a return. You got to remember how radar works. It's got to be able to bounce, hit a return, and come back. So, being my former military days, I worked with radar stuff. And why is some airplanes, you know, can't be seen by radars because they simply don't have a return on the radar. So we have to consider the items that we're trying to avoid at least have a signature for the radar to read. So it could be challenging a little bit for, you know, that time. So
yeah, fair enough. Now Anthony's asking, I suppose, the big one really, and he has lain down in anticipation of the answer. Now he's lying down. Can you tell us the price, please?
So we're coming with an opening price at $8,999. So less than $9,000.
Let me just type that in the comments. That was $8,999. Yeah, $9,000 for cash.
$9,000. Yeah, USD.
Right. Okay. And I suppose because I don't have it off the top of my head, is that competitive with the thing that this is very similar size to?
Similar to the other
There's another manufacturer with 3 letters that's got something of a similar size. Is that competitive? I don't know. I don't play in this game.
Well, here's the funny thing. It's like, okay, I'm gonna take a shot of me just so you can see me. So, and when you're looking at the other 3-letter competitor, I'm guessing you're referring to the M30.
Yeah.
This is much smaller than the M30. I've already seen a lot of comments that we copied DJI. However, when you look at the form factor, it's very much what an Evo looks like, even a smaller Evo. nano. It's we've got this nose
Like
up on the
this.
front. It's just so I refer this to a chunky version of our V3. And this is funny because Max, my coworker, general manager, he's part of Autel.
Don't say he's chunky. Don't say he's chunky. Don't say he's chunky.
But it's not because it's gray. Here we'll look across the table. Everything in the table. So go ahead, right here. We've got gray, we've got red, we've got orange, we've got white, and they're all, like I said, that same similar form factor. So there's so just because we make it gray, there's no copy by any means on that. It's already just a form factor that's a little bit bigger or different than our own. So that's the only difference. No difference that. We also have up on the top, we have our accessories that we can still use. So under here, we've got two small screws, just like our normal accessories. These were already available and already working with our Evo 2 line. So add that to that. We've got our spotlight, speaker, those accessories as well. So I would say it's a bit more, not so much M30, and it's a lot smaller when talking being able to pull this one out. Doesn't quite fit the bag, but when it's all folded up, comparison to the nano. So it's still a fairly small form factor that can be folded up and ready to go.
And it's 40-something minutes flight time, I think, isn't it?
One more time.
40-something minutes flight time?
Yes, 42.
42. Now, what's the real flight time then? That's the one in the brochure. What can we really expect?
Real practical guy. So, yeah. So, depending on your wind conditions, depending on your environment, how you're flying in the Alps or not, of course, that's going to change. Yeah. But
Oh, and funny you mentioned the Alps there. It's got quite a high service ceiling, hasn't it?
Yeah, in fact, it's a very interesting thing because they're close enough to go to high mountainous areas in R&D testing. That's where they go. They basically go take them up to these high areas, and they do real practical testing. It's not a ceiling height guess.
Right.
It's a real test.
It's a real thing.
So let's talk about. You want to talk about the mesh?
Oh, in a minute. I've got a couple. I've got a couple of questions from the viewers. So somebody from LinkedIn wants to integrate a parachute. Is that on the cards?
One more. Sorry, one more.
A parachute. Any chance of a parachute?
Likely not. As much as I love parachutes, as Jon Mc Bride, I hate parachutes. They sometimes they're effective, sometimes they're not. If you're just putting it on the top to be as a checkbox, and just say, hey, we're trying to mitigate the safetiness of that, great. But most of the time, I'm not seeing very many effective parachute designs. So we don't have anything right now in the line of parachute, but there could be possibilities of third-party guys making them, putting something, strapping it on there. Not an extremely heavy drone, but it certainly would cause damage if it came down.
Yeah, but as you've said, that really is kind of a tick box item in a lot of places, without a lot of thought to actually what might happen if you inadvertently deployed a parachute. We'll just go, oh yeah, it's got a parachute, makes it safe, perfect, carry on.
It's the only time I've ever seen them go is when they do it not on purpose. So at least my experience.
I have similar experiences with parachutes on fixed wing aircraft. I know what you mean. Also being asked in the comments, any estimate on UK and Europe stock?
As soon as we have them available. So we're still looking at a timeline somewhere to finish development at the end of March, so 3 months out. And so just, again, we always want to see what the market thinks, what we're going to do. There's always a little time for improvement on launch. However, when we get a little bit of that, there's always time to make sure it's ready.
I get the feeling the market's quite interested. That's what I'll say.
Oh,
I get the feeling.
I would dare say the market is interested as well. So, we have certainly want to be getting it out somewhere. You'll be able to sizzle. As we do testing, we'll be releasing videos and different things on how it's working up until the point of delivery. So I would expect probably no later than mid-March, maybe April, to get it into the European market.
And also from Doverance, was there any consideration to using ultrasonic sensors in addition to the radar for short-range side detection of radar transparent materials? Well, that's a big one.
He sounds like a techie guy like me. I like that stuff. Consideration always to be able to do any type of level. I mean, the fact that no one has considered really put even a radar in the system. We can talk a little bit about dragonfish because we've got some new things for the dragonfish as well. Dragonfish is also implemented with radar.
Sorry to be, and dear viewers that are here, I have had no conversation with John, and this is probably impresses me more than anything else. I've had no conversation. We haven't set it up. Sometimes, in fact, whenever it happens, whenever a company asks me for a list of questions that I'm going to ask them, I just say, tell you what, we're not going to do it because I can't stand that. And John he's coming in, and this is as is. There's no rehearsal. This is as is. So when I'm asking him to look at the dragonfish next, the reason I'm going to do that now is because I'd like to talk about what I think. Hello, Johnny. Hello, Rat Race. Hello, Anthony. What I think the most exciting thing is, which I also think is a first. So that millimeter wave radar is a first. But I stand under correction. And other than big military systems, I think that mesh is the first one that's out there. And that is a huge thing. If I understand how it works correctly. So maybe, John, if you'd be so kind, you could lead us through the mesh, and then I'll come with the foolish questions straight afterwards.
Absolutely. So one thing that we're always challenged with when we consider public safety applications, maybe, I don't want to call it military, but we have some level of that, how it kind of works in communicating with multiple drones or multiple different systems. What we're doing is the mesh is specifically in reference to how our communication path is working with different devices. Some people look at the image here they look at the multiple pathways, but they think it acts like, or it's going to act like a swarm tech. But that's not what we're talking about. When we bring in something into the mix, such as our mobile awareness kit, and communicating with the drone. So as we're communicating here with the drone, we have a guy on the ground that has visual here in a closed loop system, a mesh system in which all drones, there could be multiple drones, dragonfish, the mobile awareness kit, all talking to each other within that system. And then what does that mean is that when you're in the ecosystem of communication, you do not have to rely on 4G, 5G, LTE. We were just deployed down there. We had dragonfish deployed down in Hurricane Ian in the United States recently. And they try to get information out. It's a very difficult spot. We come into more rural areas that don't have basically good connection to move data back and forth. We're trying to solve that to have an ecosystem of communication between all parties. And then we can also, on the mobile awareness kit, we can ping each other on where we are on the map so that the pilot of the drone is actually aware. So think of like a wildfire or something like that. We have a wildfire, not great communication, streaming back to the command centers, but I simply just take my ATAC here and I click on it. It pings where the hotspots are. I can put multiples down, and these pilots are aware, so they can guide units correctly or address the problem.
You just said something that I was going to ask, because this sounds very like Android Tactical Awareness Kit, and you just said ATAC then.
Well,
is it related to it?
Yeah. Well, because you can, or I got a placard here, just because we're calling it the mobile awareness kit, but if you're
Yeah. Okay.
adding the A to it, Autel mobile, we're AMAC.
Oh, okay.
AMAC
Okay.
here.
Okay.
AMAC
Okay.
instead of
Oh, not
ATAC.
ATAC. Nothing to do with
Yeah,
ATAC then. But it
yeah.
sounds very like it. So, but it is probably, I mean, funny you see now, he rants. Right now, I'm involved with setting up an ATAC instance for mesh networking communications between delivery drones over a very large area. So this is so you've got so blast. That's exactly what I need right now. So in theory, so what is that sending back position? What else? What else is going over that mesh network?
So really, we've got video, we've got
You've got video.
location data of each person. We have telemetry data. So even if you have multiple, I mean, again, if we have multiple people on this connected drone, we can pick what feed we want to see where it applies to where my position is.
So I'm the fire commander. I'm sorry to interrupt you, John. I'm excited about this. I'm sorry. I'm the gold commander, they'd say in England. So the man overseeing everything somewhere in a building somewhere. It then gives me the ability to look at the feed of John over the hill over there, Dave over there, Ian over there, select a feed and see what's happening and give myself a bigger situational awareness. We might have put one of your dragonfish just in an orbit overhead our HQ, whatever it is, be it a van or a building or whatever. And that's acting as a communications relay. And so you, John, might be over the next hill, well beyond normal, what we call BV loss to myself. But then you can see another Ian is over the next hill or Sarah's over the next hill. And as long as you, John, can communicate with Sarah over the next hill, that'll work its way back to me in the. Yeah. Sorry, I'm not putting this very well, am I? But I think that's what a mesh means.
You're doing very well on the explanation because that's very similar. You've got so even though you may have radio communication and talk to each other, another one that we'll be able to do is actually text each other or again ping a location and actually send messages on whatever instead of having to do it here. It's recorded, it's located, GPS locations are on here. So I mean having the whole point of the mesh is again communication paths without other systems that have to be used to do so. If I have my cell phone, I can call. You know, it just you take all that out of there, and I have an ecosystem now that kind of helps with that comms.
Yeah.
And where we are located on the ground. So
yeah, we're off to a fire or some major incident where everything else is gone. At least between us, we have an idea of what's happening. And I suppose somewhere here, if someone in the loop does have a good internet connection, then all that data can then drop out to the internet wherever that is, and then allow somebody further away to do that.
We do have that possibility to share, you know, but it's because it's again a multi-network system, multi-points of data input into the system. There should be, I mean, we would work on a program called Sky Command that kind of hopefully kind of moves that as well out to the internet if we have it available. So, but when you're just a single operating, you know, fire truck or something like that, multiple things, everybody's up in the air and that communication is happening. That's really you can't do that with any other drones. You know, to be able to communicate like that via the ecosystem.
Yeah, that's I must admit that is, you say, you know, your cameras and all sensors, and I'm afraid I do go a bit okay. But as soon as you said mesh, it's like, whoa, really? Wow. That's like, because so in theory, would that mesh come right down to this sort of thing, right down to the little Nano Plus?
Yeah. Well, so in theory, it could work in Nano Plus. In theory. But we
Well,
have to
because
make
I mean,
sure.
well, let's think about the situation. What's it really going to look like? It could look like some people walking out into the fire or looking for somebody, the search and rescue thing, and they won't be necessarily carrying the biggest thing you've got. They might have one of these, and if at very least, if all it did was, so they've walked out into the distance, they've gone over 2 hills. If they popped up in a no communication situation and spoke to the dragonfish and said, "We're all here. We're ops normal. We're alive." That's as valuable as spotting a somebody. He said in an enthusiastic manner. Do you understand what I'm trying to say?
I do.
If they
So
can,
I kind of, and again, it's nano and light are kind of intended to be a little more on the consumer side of product lines. So I'm not saying no, but I'm kind of saying it's not really been a thought process. But for your example, because it's almost assumed with any, and a lot of brands, well, specifically the three-letter brand, when they make something, you hope it fits with the whole show. It somehow works with the whole show. But it's hard, in some capacity to develop, where we're a year later and we've got, new chipsets and new communication sets and new things where, it's not quite as easy. So I want to say no, it's likely not going to work, but you never know how the engineers might try to make it work. But I'm no promises on that.
That's okay. It's okay.
But I do know Dragonfish and the Max more than
Can we look at the dragonfish now then?
Let's go
The
over there
very
and take a look at
improbable. Well, now the kind of the most unique thing about this, in some ways, is it's the highest aspect ratio wing of a vertical lift machine that you see out there, and that's very different. You're very alone in having that high aspect wing.
Yeah, so it's a beautiful, beautiful queen cord. I will tell you that. And I'm an old RC guy, so I'm radio control guy. Since I was 12 years old, 35 years, 36 years now. Do the math, and I'm a pretty old guy. But beautiful. I mean, when I saw the dragonfish, I was completely enthralled by the way that just the overall what it was capable of, and as well how that high aspect ratio wing would affect the flight time, of course. So up here on this one, now this, as far as size goes, let's just kind of get that size before we come back in. Pretty big. Pretty big.
So what's that in meters? What's that wing in meters then?
Pretty big. So we're probably 3 meters wide on the wingspan. So 3 meters wide. And what we basically have is that my challenge is when trying to make any type of VTOL that's kind of engineered for what it's going to do is public safety was always the wind and weather. It was always trying to take off a foam airplane in some of those types of conditions. And you got to remember, it's an airplane, so we are very sensitive to the wind demands. And even at that, because of that wing and the shape of the wing, we also, if it's too windy, nose into the wind, it's a challenge to get it down because it's an airplane. It still wants to fly, right? So the design here, when we go ahead and turn those props up and we are in vertical takeoff, then we have these changing our propulsion direction. We start to get the airspeed fast enough to then utilize the wing. Main motors will then basically shut off, stay aerodynamically straight. They are electronically locked. They don't free spin. They are locked straight. And then we have some level of efficiency on the whole system. So we're only using the outboard propellers for propulsion. And we have small adjustment angles to do banks and turns, but we are limited just because of how much we're not flying this like a 3D airplane. So we're limited on our bank angle, and our turns are very wide. So this keeps our air time up in the air, so we're not doing anything egregious or crazy. However, when we go to change altitude, we have still an elevator on the back. So on the back of the aircraft, you have a functioning running elevator that is going to help us get that nose up in the air. And on the Pro and the Light, we have a VTEL design. So a VTEL design, and again, this is only in forward flight, in transition, in which it helps to get the nose up and down and change altitude. And our climb rate is fixed, so it's going to climb at a certain fixed rate, drop at a fixed rate. It's not going to do anything outside of anything crazy. We have no rudder, so we're not, again, trying to kick it in a yaw turn. But as I've got approximately, this is the best guess, about 500 hours on the Dragonfish flying. And, most of the time I'm flying the standard for demonstrations and training. So I do a lot of, we've got about 30 units here in the United States that are actively being used with departments, ranging from Border Patrol use cases, Marine use cases, a lot of different applications. But they're mostly, pretty much 99% public safety. I always get this question, and I hope I can get this for your audience because I always get it. When will it map? And I see the ability to do this with mapping. However, this aircraft is $150,000 to $175,000. Seems really like an expensive item to do mapping with when you have other products that are made to do mapping. That's all they do.
Yeah.
So can we map with it? I mean, we can. Is it the most efficient, most effective with something so expensive when you're talking a dollar amount every time you put it up in the air? Not necessarily, but those that have it have our payloads, so we've got, different smaller payloads that are available. We'll talk about this one here in just a second, but our smaller payloads and capable stuff are really meant, again, for real-time decision making that I'm doing right now. They're not necessarily for documentation of mapping. Now, we may make a better mapping camera with a better megapixel count. However, that's how you have to kind of think of Dragonfish. It's Overwatch, it's reacting, it's tracking, it's doing all of that real time. So here, everybody gets caught up on the size of those thermal sensors, and it's kind of baseline to go ahead and talk that the 640 is kind of a baseline sensor. However, what we have here is a 1280 sensor on our T3H. So you're much bigger as far as that sensor goes. This is also the same sensor that I have on my L50T that is hanging on the front. So a much bigger sensor, 4 times the size as a standard 640. So things are getting smaller. They're getting better. Still expensive, but it's getting smaller.
And they don't retract at all. They're always in all variants. The sensors sticking out in the wind. So
I have it, sensors in the wind. When you're talking the ball configuration, a flat configuration. It doesn't seem to really affect the condition in which I'm using it or the reason I'm using it. I don't see it shaking. It doesn't have any destabilization. It's actually quite amazing figuring out that I'm moving sometimes 60 to 70 miles an hour, and I can easily share video with you at one point or another of a downwind turn at 93 miles an hour, and you wouldn't even know that it was moving that fast, and that the cameras, you wouldn't even know that.
I think I'm more thinking of my landings occasionally. I'm more so Bruce who's in the comments. Bruce Simpson's landings are definitely, we've got to worry about those. Yeah, no, it's just it was such an expensive sensor. I think I would be inclined to want to hide it, ready for my arrival on Mother Earth. But of course, it's all automated, isn't it? So I guess it is kind of mute.
That's the winning thing about it, is that even though we have a remote we're flying from, when I do my classes, public safety doesn't need to, we don't need to use the sticks necessarily as a reason to pilot the aircraft. So it's this is why, speaking of training, I created what I call the ARTC, the Autel Training Center, Autel Robotics Training Center. And that is a requirement and a manufactured mandatory training if you buy a dragonfish and do the training. So it's required. I will. If you don't have the certification from us, lesson capability. And the reason why for this is not just because it's another drone. It's very intuitive and actually fairly easy to operate. But there are things that because you're changing over to a fixed wing versus a normal drone, there are major considerations when you're thinking about how to command control from the tablet, not from here. You're not doing it from here. You're doing it everything from the tablet. So the tablet has to. You're basically just controlling the payload, and the aircraft is doing everything else for you up in the air. Very automated, very automated. But when it's moving around, it's moving 48, 50 miles an hour. It has to make turns that are no less than 375 feet or 100 meters, no less than 100 meter radius turns. You have to consider how you're going to move this through space. And our training, absolutely, proficiency training has to be understood. So
is that, sorry again to interrupt you, so that really is that really where your training is more at? It's like, come on guys, think about how far away that tree really is, or just consider it before you go, and are you above obstacles of X meters high within, you know, how big is that? Is that more? That's very interesting. That's more where you're at.
We can always we can always consider that even in manned aircraft, we can always push the auto button, right? But we look at charts and we look at things because there's still conflicting things that can happen, and the human has got to make a choice. That's always going to be there. But when you are allowing the aircraft to be and flying and managing managing the mission, it could be a 50-50 chance if I pick a target on the ground and it decides it wants to go right, because that's the most effective way to do it, left to acquire that, because I'm not doing that. Now, most people are like, well, why don't you have a two-man system like a lot of the other manufacturers, drone flyer, payload operator. And to me, again, when you're doing it all, have a smart pilot, trained on what they're doing, they know where their obstacles are, they contain their flight plans to be able to do so. I've not had any dragonfish so far in the thousands of hours that they've been operating hit something, because of the training, like smash into a radio tower or anything like that. So
I mean, I've got to say, first of all, I've got to say, Louis from Portugal says hello, and says hello to John as well.
Hey,
Joe, sorry. Dare you be so honest to tell us if you've had any incidents with them, or will you keep that a company secret?
Oh no. I mean, accidents are going to happen. Users are going to make mistakes. Things are going to happen. So we have had testing crashes with firmware. I mean, those kinds of things are part of basically making the product better. So any testing that we've done are in a very contained space. We try different things, and I'm not ever wanting to intentionally see what happens. But according to the FAA, to get type certified, you have to crash it on purpose to see what the velocity is. And I'm like, okay,
Tell me, I've had to in the manned world, I've had to drop test fuel tanks and all. I've had to break things for regulators, and it's just. I haven't got the money to do it. I haven't got the money to.
No company, in the drone world, with how quickly things change, is going to really want to go down that route. To crash $100,000 machines just to see if they make a hole in the ground or if they skip off the ground. It's just because we keep changing over and over, and then that's a different form factor. That's really challenging in the drone world, but we don't want to spend too much time on it. But I get it as a challenge.
Yeah, because it's as you say, it's iterated on again. Now, Louis says I've got to nail you on the SDK, and I'm sure that's something you and he and you know. But Louis wants the SDK, and if Louis wants that, also I want the ability to do some simple mapping with this. Come on, give us waypoints. It's 2023 now. Come on.
Waypoints are there. They are there. You can set up waypoints. That's how I train. I just set up a waypoint. It has an automatic takeoff, goes to a waypoint. it loiters there for a second. That's how I'm already teaching the automated side of how to get
But
the
what about
aircraft
but
up.
what about lawnmower patterns, so I can make some simple maps, so I don't have to fly accurately?
It's in the UI, but let's talk about mapping RTK because we use RTK. So
Yes.
here on the bottom here, this is a new ground station that we have now.
Yes,
Our
I saw
mobile
pictures of that.
Yeah, so we've got a patch antenna, basically a very directional antenna. Up here, I have an omnidirectional antenna for short range. But this pushes us out with that. When it takes over and uses this antenna, 62 miles. We can get out.
Does that rotate? Is that
It
motorized?
does move. Yep, it is a transmission tracking antenna, if you will. So it does move. Yes. On the same thing, what we have here is our RTK coming down inside. So the problem is I always get this question again in the mapping capability. People don't really understand they have no idea what RTK actually means in a static position with reference to the aircraft versus RTK for mapping, for ingestion of real-time correction data every second. So we're not using RTK for mapping. We are using RTK for precision flying. What does this really mean to the user?
Yeah.
Yeah. What does it really mean to the
GPSs or whatever it is? Yeah.
What we're doing specifically is that it's really easy to know where I am. GPS. I'm the aircraft. Very easy. I got incoming GPS, watching it on the map, or seeing GPS numbers change. However, if I'm pointing all the way over there somewhere, and I want to know where that is, GPS in relationship to me, that ends up being a much more difficult thing to calculate. You're calculating this all based on where I am, what the angle of the camera is, how far the camera is zoomed in, a point on the map or a pixel on the map, and I need to give that location to anyone. So that tends to be a problem. So we use a fixed RTK base station to help with communication to the aircraft to know where it is at all times and where we're pointing. And who wants to know where we're pointing? Public safety, definitely. There's the guy that's lost. Whoever it is, it doesn't matter. That's a big deal, and we have to have this information from the RTK. Now, the other thing with RTK, when we look at that, normally the RTK is fixed. It's staying stationary. This new design here allows us to be mobile. So I can tell you engineers did a pretty damn good job on this one too. Being able to make the RTK base station move on a boat, on a vehicle, on a van, and still operate is a major deal because that has come up a lot. And we can't put our other previous base station on a boat while it's continually moving. It messes with that RTK connection. So that's a new design here. Besides it going far and having some fancy antennas and making it go far, the fact that it can be mounted on a mobile spot and go somewhere is a big deal.
Will it ingest N-trip stuff as well, or is it just standalone?
It's just standalone. So we also use this as kind of a repeater. So I've got my remote connected to that.
Yeah.
That is connected to the drone. We're running, usually we're doing 5.8, 2.4 on the remotes, but this is pushing out at 900, 800 megahertz here. So
okay, is that within ISM bands? And Bruce is asking, what sort of gain is that patch?
Yes. Technical
it's
guy.
Yes. Is it yes?
Yes.
It's yes. Okay. Yes. Good. Several.
Pretty high gain. It's actually,
several. Yes.
I need to go test it. I mean, I get first time I've seen it here at CES is them to bring it to me. So I get to take all this stuff home to my location in Utah from Vegas and test it. Gary, come on over. We can play drones all day long.
you might be able to talk to Utah from Vegas with that thing. I should imagine.
Come on into Utah.
So
one more.
You've got your box situation now, haven't you?
Yeah. So real quick, we'll come right over my shoulder here. We'll take a look at the small nest. The one thing about it is that last year we went ahead and made the announcement of the nest, the initial nest, that nest was created third party. So the conceptual idea was always there to have the nest landing on a spot, doing that, charging internal. You leave the battery in, it connects up, it charges, hangs out there until the next deployment. Cover closes, it's drone in the box concept. Nothing different than a lot of people have already kind of engineered to come up with. So the nest, absolutely, lots of applications for that. But what we're talking about in the other box, what we'd like to see is this nest.
Well, you would, because you're biased. You're biased to the dragonfish.
Well, of course I am, because I love my dragonfish. So if we take a look at this, we have to have obviously a big amount of space. This size here, we were just talking about the Dragonfish Pro, but this one here is a Dragonfish Standard. We're still about a 2 meter
cheap one.
Takeoff.
This is the hobby market one.
Yeah. And so it's going to be a fairly large box. But the one consideration here is that there's not a port for this to actually do battery charging on the deck. This is just a landing deck. We have arms here that move it so that we can get it centered onto the platform before it goes back into the box. But what I wanted to show was our battery station area. So we have the ability to instead wait for the batteries charging, which can take 2 hours or so with these batteries. In the back here, we actually have a battery, an arm that physically changes those batteries, reloads the batteries.
Robot arm.
So when so when it comes into the dock, into the nest here, we have a robotic arm picking up those batteries and then exchanging them within the ship so that it can get back out and deployed. And our turnover time still to be determined, because when we close it in, change the battery, the door closes. I've watched them run it again, first time I've seen it. So you're probably looking a couple minutes to then get it back out and deployed. You're not trying to restart the aircraft, but there's the technology. Go ahead and do kind of a simplified hot swap, if you will.
So when it's sat in the box on standby, does it keep Zipline do a clever thing by putting the GPS in the batteries? Does it keep itself basically alive, ready to go, and then you push it out, or is it coming?
Yes,
or is it?
Yes,
okay,
by the time it gets out here for a reset, so yes, you want to be able to kind of deploy quickly or back out quickly if that's the case. But even when I do it by hand without it doing automated, and I have to remove the batteries, restart the battery, we're talking a 30-second maybe turnaround, 30 seconds or so, maybe 40 seconds. Turn off the aircraft.
Is it dual GPS in the Dragonfish or single GPS?
So we have GPS, GLONASS, Beidou, Galileo. We use four systems with that on the RTK.
But I think what I'm going for there was the using it for yaw, having dual two GNS systems to aid with yaw. I don't know if you do that at all.
No, I'm not familiar with that one. But
oh yeah, it's really cool. You can really get your yaw sorted out with dual GPS as long as they're separated out far enough, and that's the opportunity that you have with that airframe.
I know what you're talking about. So when we're talking using RTK in general, there's a couple of positive things. We eliminate 2 sensors. When you're talking yaw specifically, is that kind of what we're referring to? Is orientation of the aircraft?
Yeah.
What direction? So you're able to eliminate compass. The compass theory is learned, the compass sometimes has some spaces, and that is an advantage of using RTK for positioning. We also eliminate barometer. So barometer over time. This aircraft flies for almost 2 hours, and in that 2 hours, you can have some pressure changes that would basically affect your AGL change. We've already seen this on mapping on extended amount of flight time that they have recorded altitudes that are different for some reason, and that's because they've been flying for an hour and a half, and those pressures change, which also changes the report of your data of where your altitude is, AGL. So those are really good considerations. I mean, another techie smart question. So here's our
I know,
RTK antenna.
nerdy.
Yeah, smart stuff, and I hope I answer it. Don't sound like a fool.
No, you have. It
So
no, it's just it's what I want to say. It's just one of the advantages of having that long airframe that I
yeah,
immediately thought of.
those are your
There's advantages to that.
antennas. Yeah, you got
Yeah,
two
there
of
you
them.
go.
Yeah, but
There
it's
you
got
go.
that offset angle, and
Yeah,
all the dragonfish have that
yeah.
designed in already with two RTK antennas on top.
I can't remember the numbers. Are they like F9Gs or FG9? Someone in the comments will remember the numbers, but there's something like that. F9. So they're pretty cool. The modern GPSs are pretty cool, really. But obviously, sensor fusion is the key with that. So we've launched our Dragonfish from the box, and this generally then it's not going off the map stuff. It's going off to surveil an area for some reason. So we might be in a ski resort, and we might be looking for an avalanche, or some incident has reported. Is that sort of, or looking for hill climbers or whatever? Is that sort of the
single use use case? You can do a lot of things with that. But where I see this to be most advantaged is to have multiple nests on a very far, think again, if we're moving at 40 miles an hour with a little bit of wind hitting us, we're moving 40 miles an hour, and I can fly for an hour and a half. To get 40 miles, it's going to take me an hour once I'm in that cruising speed. So 40 miles of nest to nest, And so
nest to nest?
Yeah, we're talking basically being able to put this on a border and to check border type level stuff, corridors in which they could be miles long, railroad tracks also miles long, to do any really quick ISR surveillance overwatch. Now, some people are like, well, that's pretty far. 40 miles is really far. But you also want to consider that if you find an incident multiple times on that route from box to box without a return time, you have to space them out logically to basically go, I see something, document it, trigger it, whatever, move along. I see something. Because you want to investigate. That's the whole point. Investigate what the problem is.
But that's your pattern of life. That's then down. You're getting an image is one thing, but then you need to take that information, which you can do with your mesh, chuck it into something that's going to look for a change of pattern of life over multiple flights. So, as long as you've got a sensor in the air, you're going to. Was affirmation talking? This, isn't it? I get it.
So,
I get it.
The idea of nest to nest.
But then one has to ask then, if you're going nest to nest to nest, so where's the delivery drone?
Where is the delivery drone is the question. So how big
exactly?
How big can we make this design? Is it something that where we have again most designs boom design, something in the back pushing. We haven't really pushed too much in the commercialization of delivery with the Dragonfish right now. But I will say there's possibilities. There's always possibilities in recreating tech to be able to do it. And I've heard from little bees that maybe we have engineers working on some pretty cool stuff. So,
Bruce says the delivery drone's being shipped by FedEx, so it'll be several years late. But then, so coming out of the box now, Zipline has a very handy method of, because I initially thought Zipline was the work of madness until I saw the rail and saw their landing solution, and they chuck that thing so fast up the rail that it just has to fly, regardless of which way the wind's going. But coming out of that box, surely you're going to be a little bit wind limited from quartering winds and stuff like that. That surely must have some limitations there.
So to basically, again, make decisions, we don't always fly Cessnas when it's freaking beating at 120, 30 miles per hour, right? We got to make a decision. So yes, weather is going to be a factor in making a decision. that's with any design. I don't care who argues with me on that. But you bring up the probably more critical point. What if the box hurricane level? Would you have a hurricane level rating on here for the box not to go anywhere? Would you have a good high wind rating to make a decision? So up here on the top, we have our antenna array, but additionally, we are able to visually monitor weather conditions and things where the box is to make that decision. So we don't want to deploy the box without knowing. These could be miles and miles away, so hundreds of miles away from each other. So you definitely want to consider how that, weather condition at the location is. And this is what I did in the Marine Corps, by the way, fixed equipment for mobile weather stations out there in the middle of nowhere. And we were also forward LCs. That's what I did in the Marines, was a technician on weather equipment. So, but we have this. We have to have it. You have to have that information internally in the box as well. We have cameras monitoring the operation. So, and I don't know if you can see it, but there are smaller cameras inside. But one thing I want to say is that environmental area, it's got to keep a nice environment in here. We have insulation on the side of the box. We have, so in hot weather, cold weather, things like that. So if it's raining like crazy, we basically don't want this this door with a whole bunch of water all over it that's closing and capturing all of that inside. So of course you have to kind of consider where you're going to put these things to operate that the best.
A good question from Christopher. So no anemometer. Is the camera looking at a windsock? But that would be a perfect solution to look at a windsock.
Well, this is an initial, here you go. But we'll put in, I've got my own built-in anemometer built in, so.
But I think, and I don't want to sound too much like an Autel fanboy, but this is going to make me sound like an Autel fanboy. But at least it's considered. There's several drone in a box solutions where it's not, if you look at it, it's not in the consideration. So it's a drone in the box. It's always going to have an operator on site. I think we're hopping a skip away from the drone in the box being on an oil rig or being at some big, very dangerous bit of infrastructure where it's best if a person's not there going, hang on a minute, let me look at the weather. No, I don't think so. I'll go, and they'll have access to forecasts from the internet. Will go, oh no, look, there's a gap in 2 hours. I'll go in 2 hours time, and it will. I think we're a hop and a skip away from critical infrastructure inspections being completely autonomous. I really do. But anyway, rant over. So it's good to see that you've got it in the box there. It's that thinking ahead thing.
The concept, this is a sorry, you're okay. The concept idea of drone in the box is, again, nothing new. Once you put it out there in the field, once they're doing work, we got to see what those limitations are. We've got to see how the designs go. You're not going to get it perfect the first time. I can promise you that. But the idea overall has been to do drone in the box, use it so that we can set it off and do a mission, repetitive missions. I see this as well. There's a lot of applications. Security around an area, every hour, every half hour, it just flies around. You have somebody watching the screen, making decisions on whether or not there's something there, and we don't have to have a guy go out there, turn the battery on every time. So drone in the box is definitely something in which we're going, but I think drone in the box would be I think we could develop faster. To be honest with you, drone in the box idea, I think we can develop faster than scaling drone delivery, because drone delivery is going to be great with stuff, but you've got stations, you've got major. But just take that box, go put it in a substation. It does a routine inspection every week. That's easy. That's easy to scale as long as we can get in agreements with regulation. So the person is not there. They're not there to monitor. They're monitoring what they see, not necessarily that. Technicians, can you imagine, this is sitting out there for, months and possibly a year, that you're going to have technicians built up to basically repair, fix, or even update and do things like that. That seems to be, a lot easier to scale once you do
Yeah. And of course, really critical infrastructure might even have a danger area around it. So it'll even have its own segregated airspace anyway. So, you're asking the regulator, can I operate a thing in segregated airspace to do a job of work? Much easier than, as you say, delivering to the high street with a taco or whatever. No, it's definitely. Grill him on dollars. It was 7. Was it? How was it? I've got to scroll back up. Was it 9,000 dead or 8,000 dead? I can't remember. Oh, on the dragon. Do you want the dragonfish, Louis, or do you want the earlier thing? Which one do you want, Louis? The dragonfish it's cheap. From Louis, for a man like yourself, it's cheap. You probably use them to.
Gary, I'm sorry. I was just going to say goodbye to some of my guys that are heading out for CES. I did want to say, I have an absolute fantastic crew here helping out with CES. I have Keith Gerhardt here, who's one of my best sales guys, I guess you could say, and Joe, Joe is my Dragonfish current expert and helping out with some of the sales here. You guys take care on a flight. Yep, I'm sorry. Take care. Okay.
Oh, look at this. I've nearly kept you for nearly an accidental hour, and I didn't know. I'm sorry. I didn't know.
We can talk all day about it.
We've nearly been talking for an hour. That's mad. Yeah. I didn't realize that. So I should let you go. You're a busy man.
Hey, as long as you have people watching, of course. I mean, the big thing is that always to be informative on what we do. Always being able to show there is direction in the industry. Always being able to have these healthy discussions on not just
I know.
but also the other things.
Bruce asked earlier, are there many drone stands there this year at CES? From overseas, it doesn't look like there are many there this year.
No, I think 2, and I can't remember the name of the other company because I've never heard of it. So,
wow.
But we don't have DJI here. I don't see Skydio. I don't see micro drones. I mean, back in 2000, my first CES was 2013, and when it was they didn't have drones. It was like this: couple booths, couple manufacturers. But then all of a sudden, they had a whole drone area. You had Zero Tech, DJI, Autel, all of these major companies were bringing in some Walkera, all kinds. And now that, I don't know if it's not because it's not popular anymore, but maybe again, consumer level, now people kind of get it on the consumer level.
Yeah.
So
well, I'm glad. I'm glad we've gone past what I consider peak drone hype. I'm glad we've gone past that because now it's time to actually just start working and crack on with it. It's cool that it's not cool anymore. I'm not putting that very well, but it's just time to work now. It's time to crack on with the work. And people are doing amazing things with drones, taking amazing images, making amazing maps. And talking of that, Christopher's asked timeline on mapping payload for the Max. I guess he means a sensor. So is there a timeline for a mapping payload for the Max?
I don't have a specific timeline, but definitely by the shoot that by the middle of the year. If you're really doing the mapping payload right, you've got to make sure you do it right. So, and you've got to make sure you've got the right information for the test. And I've always been under the assumption that most manufacturers just don't put out crap. If they do something well, they do it. And the workflow depends on how well that camera works, how big the sensor is it a global or rolling shutter, all of these factors. Does it have RTK connection? Does it have, to make sure it's an effective tool for mapping. We can always just do basic mapping. Even I have generated maps with your Nano. It doesn't have a flight app to do it, but it has GPS.
It doesn't.
Yeah.
It doesn't. That is for me. I've been flying these things for years, but that's good enough for me. I'm Mr. Joe Average, but it can make useful maps and models for me I can already, but I have to hand fly it carefully, and I may not be the most careful hand flyer in the world. But yeah,
Well, I'll show you one more thing, Gary, in the audience.
go on
And
then.
I probably do have to split here shortly,
Yes.
and I hate to cut it, but let me show you
No,
one
no,
more
no. We
thing
should.
that we've got going on. So we'll come over here.
Yeah.
Autel Mapper.
Oh
So,
yeah.
yeah, so we have a computer. We have Autel Mapper on it. The mapping software here is specifically, we're able to upload and show. And this is Autel's mapping software, right? So,
And how does one get access to this?
oh, we're getting there. How much does it cost? Yes. When do you get it? Yeah.
Yeah.
This was
Yeah.
again. I think sometimes with Autel specifically, we're kind of just test to look and see if this would be some interest in the market. And I do want to say, there's great possibilities for us to go ahead and consider, basically how we do ecosystem challenges. When you have a third party person doing stuff, it's fine. You can always consider how we get a third party person to make software, upload, and do. But when you have some relative control of what is ingested into stuff, and you don't have a barrier to waiting for design and creation and making, then sometimes you kind of win. But not all companies are really good. They don't stay in their lane very well, so software can be a very difficult one for a lot of companies. I know others have struggled with that to make their own software, and hoping engineers are doing a really good job to make Autel Mapper work so it's a full fluid ecosystem product. So
aren't we at a point now where it's pretty much understood what people need?
it's 5 times faster. One more time, Gary.
Are we not at a time where we pretty much understand now what this mapping product should be producing for the end users? We got a long way around of it to say, we know what people want from their drones now. So surely it must be easier to produce this.
Yeah, when you're looking at simplified, you're just considering how that ecosystem, how that we can talk to the customer. A lot of programs that do way more than what they really need to do. Yet you're kind of so if you can kind of nail down what simplified deliverables are available, more complex deliverables are available, and we have our market telling us as well as us manufacturers to work on those things. I mean, that's it. We're not trying to again ingest a whole lot of different manufacturing imageries, different sizes. Just know what we make and it goes in there really well. So kind of locking that down. I'm not saying it's not good for competition, but we're 5 times faster than a lot of competitors. And that's pretty good. So look forward for a little more on that. Also a little bit more information on the map. So, yeah.
At that time soon for that price, wasn't it? That time for that price.
That's
occasionally,
right.
yeah.
That's right.
Yeah, that's it. Exactly. Yeah, good. I'm glad I took all those details down. John, look, thank you very much. An hour and 5 minutes. This is thank you very much. I didn't expect so much of your valuable time. Thank you very much indeed for walking us through this. This I think is your last day at CES. Travel home safely. And we'll get you on again some other time. So thank you very much. Thank you to everybody at Autel.
Yes, thank you for even asking me to do this. I want to also thank my young lady Coco, who's been arm is starting to get a little tired of holding the camera for me, but she's done a fantastic
I did just think about that just now. I was thinking, oh my word, she's been holding this up for the hour.
Oh yeah, I'm gonna have to massage your arm, so if So anyway, thank you.
Well, we've definitely still being live. Yeah.
Yeah, really appreciate it. It's an honor.
Pleasure.
I tell you, an honor to be able to be on your show and give you some information on Autel robotics.
No. Look after yourselves. Travel safely, everybody. Dear viewers, wherever you're in the world, it's Monday tomorrow. Bad luck. Be safe out there. Bye-bye for now. 21 every Tuesday. Bye for now. End the broadcast. There we go.